You have 50,000 documents and a summarization LLM. How do you actually process all of them reliably, cheaply, and without blowing up your server? Your first instinct is a loop. Iterate 50,000 doc IDs in one request handler. Call the LLM for each, return when done. That fails immediately. The request times out, 50,000 calls take hours. Crash on doc 30,000 and you restart from zero, and you instantly hit the provider's token per minute cap. So the work has to become asynchronous and durable. You route it through a queue. The producer clips work to a rail. The queue workers pull tickets at their own pace. The cashier never waits for the food, and a burnt dish stays on the rail for another cook to retry. The rail decouples how fast work arrives from how fast it gets done. In software, 4 pieces. The producer enqueues one job per document in seconds. The durable queue that survives restarts. The worker pool, n processes that each pull a job, call the LLM, write the result. And the results store. And your worker count is the concurrency knob, that dial between throughput and the rate limit that a tight loop can never give you. Now the property that trips everyone up. Most queues give at least once delivery. A message is guaranteed to arrive, but may arrive more than once. A worker takes a job, writes the result, then crashes before the act. The timeout lapses, the message reappears, another worker runs it again. Do not believe the myth of exactly once. So for LLM pipelines, you rely on idempotency. Processing the same document twice produces one result, not two. Before the work, check, is this doc already in the results store? If yes, skip an act. And the ordering is load barring, right? The result first, then act. So a crash before the act just means another worker safely retries. But not every failure is transient. A corrupted or too long document, retried forever, ties up a worker slot and blocks the queue. So on a transient error, retry with exponential backoff, 2, 4, 8 seconds. After a few attempts, route the message to a dead letter queue. You inspect later. So one bad doc never blocks the pipeline. Now a critical concept, backpressure. If your producer enqueues faster than workers drain and you stash pending work in an in-memory list, the producer runs out of RAM. The fix, the queue is bounded, so the producer slows when it is full and workers pull at their own pace. So never accumulate 50,000 job objects in a Python list. Use a real queue library. And one lever for cost, the batch API. Both Anthropic and OpenAI offer asynchronous batch endpoints, roughly 50% cheaper. Results back within 24 hours. Use it for overnight runs. The synchronous queue when you need lower latency. So the shape to remember is the rail of tickets. The producer walks away, the workers pull at their own pace. At least once means you must be idempotent. And the bounded queue is what keeps a burst from becoming a crash.